Dear students, so far we have studied designing of Butterworth digital filters. Today I will take up designing of digital Chebyshev filter. Chebyshev filters are of two types. They are type 1 and type 2 Chebyshev filters. In case of type 1 Chebyshev filter, the frequency response is equiripple in passband and monotonic in stopband. Whereas in case of type 2 Chebyshev filter, the frequency response is monotonic in passband and is equiripple in stopband. Whereas in Butterworth filter, as we have studied, the frequency response is monotonic both in passband as well as the stopband. And these two frequency responses are for a Chebyshev low pass filter of type 1 and type 2. And in this chapter, we will be only studying design of type 1 Chebyshev filter. Design of low pass digital Chebyshev filter. Like in case of design of low pass digital Butterworth filter, here also first an analog filter is designed using the given specifications. Then the analog filter transfer function is transformed to digital filter transfer function by using either impulse invariant transformation or by using bilinear transformation. So it is necessary for us to first learn designing analog low pass Chebyshev filter. For designing a Chebyshev IIR digital filter, first an analog filter is designed for given specifications. Then using the transfer function of analog filter transfer function of digital filter is obtained, that is h of z is obtained by using either bilinear transformation or impulse invariant transformation. So now we will see how an analog Chebyshev filter is designed. The magnitude response of type 1 low pass filter is given by h of j omega absolute square is equal to 1 upon 1 plus epsilon square Cn of omega by omega c squared. Here epsilon is attenuation constant and Cn of omega by omega c is the Chebyshev polynomial of the first kind of degree n. The attenuation constant is given by The attenuation constant is given by 1 by AP square minus 1 raised to half or under the square root, where AP is the gain or magnitude at the pass band edge frequency. Denoting omega by omega c by x for small values of n. The Chebyshev polynomial is given by Cn of x equal to cos of n into cos inverse of x for absolute of x less than 1 and cos h of n into cos h inverse of x for absolute of x greater than 1. For large values of n, Chebyshev polynomial is given by the recurring relation Cn of x equal to 2 times x into Cn minus 1 of x minus Cn minus 2 of x. But to calculate C2 of x, we need C0 and C1 value. They are called as the initial values of Cn of x. and they are C naught of x equal to 1 and C1 of x equal to x. So right here with initial values C naught of x equal to 1 and C1 of x equal to x. The transfer function of the analog system can be obtained from h of j omega magnitude square by substituting for omega equal to s by j. Therefore h of s into h of minus s equal to 1 upon 1 plus epsilon square, that is attenuation constant square, Cn square of s by j by omega c. For normalized transfer function, let us replace s by omega c by Sn. Then h of Sn into h of minus Sn is equal to 1 upon 1 plus epsilon square Cn square Sn into minus j. If I take this j to the numerator, it will become minus j. For the above transfer function, we can determine two n poles which are given by the roots of the denominator polynomial. the poles of this transfer function symmetrically lie on an ellipse. I hope you all know what is ellipse in S plane. So what we wrote above is transfer function for an analog system. Now we will write a transfer function of analog Chebyshev low pass filter. We know that filter has to be stable and causal. For that, the poles of the transfer function should lie on the left half of S plane. Actually, for the transfer function of an analog system, 2n poles are there. Out of that 2n poles, n number of poles will be there on LHP of S plane and remaining n number of poles will be on RHP of S plane. When n is even, all the poles are complex and exist as conjugate pair. And when n is odd, one of the pole is real and all other poles are complex and exist as conjugate pair. Therefore, the transfer function of Chebyshev filter will be a product of second order factors. For a stable and causal filter, I hope you all know what is the meaning of stability and causality, because you all have studied signals and systems subject. The poles should lie on the left half of S plane. Hence, the desired filter transfer function is obtained by selecting n poles on left half of S plane. This is very important fact. When n is odd, one of the pole is real and all other poles are complex and exist as conjugate pair. Therefore, the transfer function of Chebyshev filters will be a product of second order factors. Normalized Chebyshev low pass filter transfer function. Let n be the order of the filter let h of Sn be the normalized Chebyshev low pass filter transfer function. When n is even, h of Sn is given by product of bk by Sn square plus bk into Sn plus ck for k equal to 1 to n by 2. And when n is odd, H of Sn is given by B naught upon Sn plus C naught into product of Bk upon Sn square plus Bk into Sn plus Ck for k equal to 1 to n minus 1 by 2, where Bk is equal to, that is this constant coefficient of Sn is equal to 2 times yn into sine of 2k minus 1 into pi upon 2n. Ck equal to yn square plus cos square of 2k minus 1 into pi by 2n. And C naught is equal to yn, where yn is equal to half inside the flower bracket have a square bracket, then again a round bracket, 1 upon epsilon square plus 1 raised to half plus 1 upon epsilon square bracket complete raised to 1 by n minus square bracket round bracket 1 upon epsilon square plus 1 raised to half plus 1 by epsilon square bracket raised to minus 1 upon n. This minus sign is very important, otherwise you would get 0 result here. For even values of n, the parameter Bk are evaluated using h of Sn at Sn equal to 0, that is 1 upon 1 plus epsilon square whole raised to half or under square root. And for odd values of n, the parameter Bk is evaluated using h of Sn at Sn equal to 0 equal to 1. While evaluating Bk using above equations, it is normal practice to take B0 equal to B1 equal to B2 equal to dash 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 equal to Bk. That means all Bk values are equal. Now we will write unnormalized Chebyshev low pass filter transfer function. The unnormalized transfer function is obtained by replacing Sn by S by omega c in the H of S. Where omega c is the cutoff frequency of the low pass filter. Let n be the order of the filter let H of S be the unnormalized transfer function of Chebyshev low pass filter. When n is even, unnormalized transfer function H of S will be product of Bk upon Sn square plus Bk into Sn plus Ck at Sn equal to S by omega c. That is equal to product from k equal to 1 to n by 2 of Bk into omega c square I am writing here simplified h of s after taking LCM by s square plus bk into omega c into s plus omega c square into ck. And when n is odd, h of s will be equal to b naught upon Sn plus C naught product from k equal to 1 to n minus 1 by 2 of bk by Sn square plus bk into Sn plus ck at Sn equal to s by omega c. If we substitute for Sn equal to s by omega c, then we will have h of s as b naught into omega c by s plus c naught into omega c product from k equal to 1 to n minus 1 by 2 bk into omega c square upon s square plus bk into omega c into s plus ck into omega c square. Dear students, I will stop the class here and continue in next class with order of analog low pass Chebyshev filter. After that, we will take design problems. Thank you.